Interacting linear functions, linear systems. Jerry, Alicia, Calvin, and Marissa wanted to test their car's gas mileage. Each person filled his or her car's gas tank to the maximum capacity and drove on a test track at 65 miles per hour until the car ran out of gas. The graphs given below show how the amount of gas in the cars changed over time. This is a volume of gas in gallons graph. And this is the amount of time that it took. Number 1, whose car has the largest gas tank? And explain your reasoning. At time equals 0, the one with the greatest gas tank was Jerry. Because everyone, based on this information, each person filled his or her car's gas tank to the maximum capacity. Okay? The maximum capacity. So, this one, the information given states that each person filled his gas or her tank to capacity. Jerry's car has the largest tank because at 0 hours his car's gas tank is the greatest volume. Alright. Number 2, whose car ran out of gas first? Well, as you can see, Alicia's car is the one who ran out of gas because her car reaches a volume of 0 in the shortest amount of time. Here is where she was full here in the shortest amount of time it took her to have a 0 on her gas. Number 3, whose car traveled the greatest distance? And how does knowing that they all traveled at 65 miles per hour help you know who traveled the greatest distance? Well, as you can see, for number 3, Marissa's car is the one who traveled the farthest because it took her car the longest time to reach a volume of 0. Here's where her volume, the volume of her tank is 0 gallons of gas. Since distance traveled is rate multiplied by time, and Marissa's time was the greatest, she traveled the greatest distance. Number 4, determine whose car gets the worst gas mileage and how do you know? Describe how you use the graph to make your decision. Well, Jerry's car is the one that gets the worst gas mileage. And we can tell this because his graph has the steepest slope right here. Gasoline is being consumed at a greater rate. This means his car's rate of change is decreasing at the fastest rate. The absolute value of his rate of change is the greatest. Okay, the rate of change represents the number of gallons used per hour of travel. Poor Jerry. Number 5, how are Calvin's graph and Marissa's graph similar, and how are they different in terms of the given situation? Well, here's Calvin, here's Marissa. It appears that the linear graphs for Calvin's and Marissa's cars' gas mileage, they are almost parallel here. That is, the ratio of gallons per hour is approximately the same for both cars. Since the y-intercept of Calvin's graph is smaller than the y-intercept of Marissa's graph, right here, and since Calvin's graph indicates a volume of 0 in less time than it would take Marissa's graph, Calvin's car runs out of gas faster. In terms of the given situation, how would the function rule that describes Marissa's graph compare to the function rule that describes Jerry's graph? So Marissa is here, and there is Jerry. Well, the function rules for Marissa's and Jerry's cars would be very different. Jerry's gas tank is larger than Marissa's because the capacity is greater. According to this, it holds more gallons of gas. So Jerry's tank is greater than Marissa's, so the function rule in the form of y equals mx plus b that represents his car situation would have a greater y-intercept. And because this car's graph has a steeper declining slope, his car is using gas at a faster rate. The absolute value of his car's rate of change is greater. In the terms of the given situation, how would the function rule that describes Jerry's graph compare to the function rule that describes Alicia's graph? There's Jerry and there's Alicia. Well, again, Jerry's holds the most amount of gas, and so his y-intercept would be greater. Okay. Jerry's car is also using gas at a faster rate than Alicia, so the slope, or the m of the function rule, would be negative, and it has a greater absolute value than the slope in the function rule for Alicia's car. Okay, and number 8. Jerry's graph intersects Marissa's graph. What does the point of intersection represent? They intersect right here. What does that point intersect? What does that point mean? The point of intersection represents the time when Jerry's gas tank and Marissa's gas tank hold the same amount of gas. The gas tanks hold the same amount of gas. Number 9. After some automotive work, Jerry is now getting better gas mileage. How would this affect his graph? Well, I think his gas mileage would increase, and so the x-intercept on Jerry's graph would be a larger number. The slope of his graph would show a more gradual decline. Instead of going so steep, he would get better gas mileage, and so it would be less steep here. Okay, that's it for today.